Hello everyone, myself AKSHAYA. Today I'm here to present about gas sensors. We'll be looking ahead what are gas sensors basically, uh, and what are the different types of gas sensors available and how are they different from each other. And we'll be looking what is the basic principle involved in the detection of gases by a gas sensor. And we'll be looking at different applications in different industries. Uh, Before starting it up, we know that all the inventions are are brought from some basic analogy from our human biology or from some biology that is present in the nature. So similarly, when we talk about gas sensors also, uh, whereas we compare it with our olfactory sensing mechanisms or like our nose, simply like where our nose can uh, perceive 1 trillion different orders, but the basic thing that brought the need of a gas sensor is like almost can't label different concentrations uh, of gases present in the atmosphere. So here comes the entry of gas sensors. Uh, Basically, what are gas sensors? Like gas sensors are basic devices that detect and measure the concentration of different gases, and they label out their concentrations to calibrate and detect what all gases are there in the atmosphere. So basically, gas sensors are used for different purposes. Based on the purpose, there are different kinds of gas sensors we will be using. The basic anatomy of a gas sensor looks like this. Uh, so looking at this anatomy, the basic three important parts of the gas sensors are gas sensing layer, electrodes, and heater coil. The gas sensing layer acts as an active layer where we have different kinds of gas sensing layers, such as which are made up of semiconductor, which are made of some polymers, and nowadays we see so many different kind of nanostructures being developed such to increase the efficiency of sensing. So the gas sensing layer is a key layer where the gases which are to be detected, or we can say the target gases, are absorbed onto the layer, and this after absorption they bring some change in the electronic structure of the semiconductor or any kind of gas sensing layer we prefer. Due to the change in that electronic structure, there will be a change that is induced in the internal resistance of the sensing layer, which will be reflected as a change in the conductance, and this will be reflected as an output voltage which is carried out by the electrodes present. So what is with this heater coil? So heater coil basically maintains a right temperature inside the gas sensing layer based on type of gas sensing layer we choose. There are types of gas sensors available, such as like semiconductor gas sensor, electrochemical, NDIR, catalytic, and magnetic. So these basically differ by the choice of gas sensing layer. For suppose we choose semiconductor materials such as tin dioxide or zinc dioxide, then it is a semiconductor gas sensor. So now where do we use them? Uh, like there are kind of very diverse applications where these gas sensors fit in. For suppose talking about nowadays, like even in the air conditioner, we see gas sensors being installed, detecting the carbon dioxide level in the room, and now we'll be seeing application of gas sensors in coal mines. In coal mines, basically we use gas sensor to detect uh, coal mine methane, that is CMM, hydrogen sulfide, carbon monoxide, and various other hazardous gases. Basically, in coal mines, there is very less ventilation and temperatures are very different. And we see a very typical and difficult situation a gas sensor has to be undergo. So, discussing a gas so why gas sensors in coal mines? They're basically used for the detection of methane and monitoring carbon monoxide levels and hydrogen sulfide detection, and also to control the ventilation. So now, in coal mines, basically we use semiconductor gas sensors. It is which basically which are like electrically transduced chemical sensors. So these semiconductor gas sensors are similar to the one we discussed earlier. Here, the sensing layer would be a semiconductor material such as zinc oxide or tin dioxide. So the basic principle remains the same. The gas is absorbed onto the sensing layer, and that brings the electronic structural change in the semiconductor material, which because of which the conductivity is changed, and that conductivity is given as an output voltage through the electrodes, and that we will be calibrated. Now, looking at a schematic diagram of the gas sensing setup, one more interesting thing in this kind of setup is the UV LEDs that are installed. Basically, what happens along with in the atmosphere, along with the gases we want to monitor, there are so many other gases which the atmosphere is composed of. So, to eliminate the disturbances or noises created in the output by these gas interactions with our sensing layer, we put UV LED. Why UV LED? Actually, basically, in dark and in the presence of UV, there is like very less response uh, given by those gases with the sensing layer. So we use UV LED to eliminate those disturbances. Next, why semiconductor gas sensors in coal mines? Because they have high sensitivity. Since you basically in coal mines, uh, the rate of destruction happening is so rapid, like the reactions happen, the explosions can happen very quickly. So your detecting material should be quite fast, and its time should be fast enough. So we need a detector or sensing material which have a fast response time, and which have a high sensitivity, and which has a better selectivity for the target material. So based on various factors such as listed here, we prefer a semiconductor gas sensors. Basically, the whenever we choose a gas sensor, the the primary qualities we check is like the amount of sensitivity we require and selectivity of towards the target gas, and its rapidness. So here I end my uh, slides and my presentation about gas sensors. Thank you.